Okay, so we did question number one. Today we are going to do question number two. Okay, the reaction between iodide ions and aqueous hydrogen peroxide takes place in acidic conditions. A student carries out a series of experiments to investigate the order of reaction with respect to the concentration of iodide ions. The student does this by measuring the time taken for a fixed amount of iodine to form. A known amount of aqueous thiosulfate in the reaction mixture react with iodine formed in reaction 1. After all of the thiosulfate ions have reacted in reaction 2, any further iodine formed is detected by using starch indicator because they form a complex that is a blue-black complex. The following materials are used. Okay. A second student looked at the equation for reaction 1 and stated the order with respect to the concentration of iodide ions must be second order because the balanced equation contains two iodide ions. Is talking about this. But remember, we cannot tell the order of reaction by looking at the balanced equation because this is related to the experimental work. It's totally related to the experimental work. It's totally. It's not about the balanced equation. Okay? It's not about the experimental procedure. So order of reaction can only be determined experimentally. Okay. Then saying describe how the student makes 250 centimeter cube of 0.10 mole per dm cube potassium iodide, starting from the sample of solid potassium iodide in the 50 centimeter cube beaker. Give the name and size of any key apparatus used. Describe how the student ensures the volume is exactly 250 centimeter cube. Okay, 250 centimeter cube. So here you have to explain how can we prepare a solution of the known concentration and also the known volume. Okay. Um, so first of all, you have to find out the moles of potassium iodide. Okay. You have to find out the moles of potassium iodide. That is zero point 0.1 into 250 cm cube. Of course, we have to convert this into the decimeter cube. Then you would be getting the number of moles for potassium iodide. Then we have to calculate the mass of potassium iodide. Okay. And then what we have to do, okay, you have to take this much amount of potassium iodide, okay, and then dissolve this amount into a beaker, 50 centimeter cube beaker. Okay. Uh, Beaker is better for mixing different chemicals. Okay. Then of course you have to dissolve it by adding distilled water. Okay. Then you have to transfer the whole solution into a volumetric flask. Volumetric flask is used to prepare a solution because it's more accurate. 250 centimeter cube volumetric flask you have to take. So you have to transfer all the contents from the beaker along with the washings. You know what is washing? Washing means that if you have some particles attached to the beaker, so you can just add water and then just you can rinse that and you can transfer the whole things into the volumetric flask. This is called washings. Okay. So then what you have to do, add drop-wise water till 250 centimeter cube. Basically, you have to make up the solution. After transferring all of the contents from the beaker, of course, then you have to add water. So you can see on the volumetric flask, we have a mark. If you are going to take 250 centimeter cube volumetric flask, then you will see the mark. So you have to make up the solution till that mark. So if you are going to make up solution till that mark, so we can say that the solution is like 250 centimeter cube. Okay. It comes in different sizes basically. It comes in different sizes. Okay. So then the student carries out experiment one using the following steps. Number one, add 25 centimeter cube of this much sulfuric acid to a conical flask. Then step two, add 20 cm cube of distilled water to the conical flask from a burette. Okay. Add 5 cm cube of 0.1 mole per dm cube potassium iodide to the conical flask from the burette. Okay. Add 5 cm cube of 0.1 mole per dm cube sodium thiosulfate to the conical flask from a burette. Okay. Add 2 cm cube starch indicator to the conical flask. Okay. Use a burette to add 10 cm cube of 1.1 mole per dm cube H2O2 to a small beaker. Okay. Add the contents of the beaker to the conical flask. Start a timer immediately. Stop the timer when the starch indicates the presence of iodine, because it would be making a complex. Starch is going to make a complex with iodine. Okay. Then the data is given to you. State how the student could improve the reliability of the experiment. Okay. Yes. Of course, whenever if you like in the previous papers, we did some questions like including the titration as well. So whenever examiner asks to improve the result, to you can say the improve the reliability of the results, of course you have to do it frequently. It would minimize the error. Okay, it would minimize the error after doing again and again. So you can minimize the error. In the first time, of course, you may have some errors, like your handling is not too much good, of course, or you're going to take you can say um, inaccurate values. Okay, okay. Let's suppose they have mentioned that you have to take 5.00 centimeter cube from the burette. Of course, if your handling is not good, so you may add 5.01 centimeter cube. It would cause an error, of course. Okay, so that's the reason. After repeating it, you can improve your like you can say experiment, and of course, it would affect your result as well. Okay. So what I did, repeat the experiment under the same conditions. Okay. Then state the independent variable in experiments 1 to 7. Independent variable is the one. Independent variable is the one which you are going to change it. Okay. Which you are going to change it. Of course, you are going to change volume of potassium iodide 5, 7, 10, 12, 15, 20, 25. Okay. So then they are saying experiment 5, the starch indicator changed color immediately. On adding H2O2, the student realized an error had been made. Suggest which step was missed in experiment 5. So, starch is going to make a complex with iodine. Okay. And iodine is produced when the potassium iodide is going to react with this thiosulfate. Of course. So, if iodine is not produced, so how the starch would work? So they are saying what step is missed. So of course step number 4 is missed. Why? Because he has not added sodium thiosulfate yet, so that it can react with iodide to form iodine. Then the remaining iodine would be detected by the starch indicator. So I have written step number 4 is missing because sodium thiosulfate was omitted, due to which iodine shows color immediately with starch. Okay, that's an error. That's an error. The rate equation is represented as this. Okay, this is the order of reaction, that is n in this case, and iodide is proportional to the volume of potassium iodide. Okay, um, n is the order. Okay, rate is proportional to 1 upon t. Okay, log into rate is equal to log k plus n log times I minus. Use the results from the student's experiment in C to complete the table 2.2. Okay. V is the volume of Ki and T is the time taken for the color to change. Give all the values to three significant figures. The results for experiment 5 should not be used. So log into V. Of course, I have to take log of 5.00. So the answer would be 0. The answer would be 0.699. 0.699. What I am doing, of course, I'm going to take a log of 5.00. Okay. And then same goes with 10. I would be getting 1.00. Same goes with 12.5, I would be getting 1.10. Same goes with 15, I would be getting 1.18. Then same goes with 20.00, the answer is 1.30, and then the answer is 1.40. Okay, I have taken log of v. Then they are saying log of 1 by t. So of course you have to divide it by 1, like 52, 57. Log into 1 by 257. Okay, so then after doing this, you would be getting negative 2.41, negative 2.08, then negative 2.05, okay, then 1.88, then 1.75, and then 1.64. You would be getting these values, okay, right? Then they are saying plot a graph on the grid to show the relationship between log v and log 1 by t. Use a cross to plot each data point, okay? Draw a line of best fit. So, I'm going to take this. Okay. Okay. Number one, at 0.699, at 0.699, of course, this is 0.7, this is 0.9, 1.1, and then 1.3, right? Okay. So they are saying 0.699. It's, of course, it would be somehow over there. Okay, it would be just like that, right? Okay, so it would be around here, 699. Okay, so really close to 0.7, and minus 2.41. Of course, this would be 2.30, 2.30. Oh, no, 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 no. It would be 2.50. It would be 2.30. It would be 2.10. It would be 1.90. It would be 1.70. Right? Okay. So 2.41. 2.41 would be somehow over there. Okay. It's 2.41. So this is my first point. Okay. Got it? Then we have the next point, that is at 1, it's negative 2.08. At 1 is this. 1 is this to 2.08. So 2.08 would be somehow, of course, it would be over there. It's 2.10. It's 2.20. So they are saying 2.08. 2.08. So it would be here. Okay, 2.08, right? Then the next point says 1.10 and then negative 2.05. 1.10 is this, of course, and 2.05. So 2.05 would be, so if this is 2.00, this is 2.00406, then 08, then 2.1. So 2.2, then 2.4, then 2.4, around it would be over there. 1.1. Okay, so it would be around here. Okay, got it. Set. And the next point is 1.18 and then negative 1.88. So 1.18 would be around, um, of course, it would be there, 1.88, right? And 1.88 per 1.18 per, sorry, it is 1.88. So 1.88 would be, it would be 1.8 and 1.9. So 1.88 would be there. So this is the next point I got. Okay. And then 1.3 per 1.75. 1.3 is this. Okay. 1.75. So 1.75 would be in between 7 and 8. That is this. I got the second point as well. Then the last point is 1.4 per 1.64. 1.4 is this. 1.64 would be 64 would be there somehow. Okay. It would be there. Now I'm going to draw the best fit line. Okay. So just like that. Okay. This is the best fit line. Uh, a timing error caused the most anomalous point on the graph. Circle this point and explain the error in timing which led to this point. This is your anomalous point. Okay, this is your anomalous point. So why this is so? Why this is so? Okay, it should be over there. It should be over there like that. But of course, this is if you are going down, it becomes more negative. So it's log 1 by t. It's log 1 by t. So let's suppose if this is around, it is around, you can say, 1 point. I think so. I think so. It is. What's the point? The point was 1.1, 2.05. Okay. It's 2.05. So 1 upon 2.05. Okay. So it would be around there. Its value should be 1 point, exactly. It's 1.9 around. Okay. 1.9.5, let's say. If you're going to solve this, so you would see that the point would be over there. Okay. The point would be online. So what does it mean? Of course, should be the time should be lower. So what does it mean? Why this error is happening? So might be possible. He or she uh, has taken the time too early. Okay, okay, taken the time too early, of course, or you can say, or he or she stopped stopwatch too late. Means he or she is not on time. Otherwise, the answer would be correct. So I am supposed to write okay, stopwatch stopwatch started too early. Okay. Use your graph to determine the gradient of the line of best fit. State the coordinates. Both you used in your calculation. These must be selected from your line of best fit. Give the gradient to two decimal places. Coordinates 1 and coordinates 2. Hmm? Okay. So what I am supposed to do that mm, you can say Okay. Oh my God. Or let's say I'm taking this one. Okay, like that. So this is the first value, that is 0.662646668, then 0.06264. So this is 0.62, and this is 1.22242628. It's 1.2 1.27. Okay, and this would be 2.442464 2.42444648 2.5. So it would be 2.424446 and 2.47 negative. And this value is 7274767878. Okay, I have taken this, right? I have taken this. So y2 minus y1 divided by x2 minus x1. This is the gradient. Okay, this is the gradient. So this is y2, y1, x1, and this is x2. So x1, y1, like 0.62 and negative 2.47. x1, y1. Then x2 is 1.27 and y2 is 1.78. x1, y1, x2, y2. I'm going to use the gradient formula. So gradient is equal to negative 1.78, negative 2.47, right? Okay. Then x2 is 1.27 minus x1 is 0.62. Got it? So I would be getting the gradient. Okay, that's easy, right? Got it? Then in question number 5, they are saying that the total percentage error from measurement is determined to be 5.25%. The true order of reaction is 1. Use this and your gradient from D part 4 to determine whether the error in this experiment could be accounted for by error from measurements or is caused by other factors. Okay, show any working. Show any working. Okay, so first of all, I need to calculate the gradient. First of all, I need to calculate the gradient. So let me calculate this. Okay. Calculator. Okay. 2.47. 0.69 over 1.27 minus 0.62, 0.65. So 0.69 divided by 0.65 is 1.0615. Okay, this